Whenever you watch a lunar eclipse, you are seeing the Earth eclipsing the Moon by blocking the sunlight to it. Similar to what happens with a solar eclipse here on Earth when the Moon blocks out the Sun to the viewer's perspective. That shadow the Earth casts is called the umbra, and you can observe this for yourself by going out and spotting the International Space Station passing overhead. When it crosses the terminator of the Earth into shadow, it blinks out. My guest today has identified a very peculiar phenomenon related directly to the Earth's shadow: transient star-like points that appear as geosynchronous objects in the sky in very precise astronomical plates taken in the early 1950s at the Mount Palomar Observatory that predate the launch of Sputnik in 1957. These are from before the dawn of the space age, yet they seem to show objects in orbit of Earth. One might expect flaws in the emulsion of the glass plates used for the exposures back then, but there is a confounding aspect to this. These objects strongly correlate with the umbra of the Earth. They go into shadow, virtually eliminating that they might be an effect of the telescope. Very strange indeed.
You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Dr. Beatriz Villarroel. Dr. Beatriz Villarroel studies astrophysics and astroparticle physics as a Nordic Fellow at Nordica, the Nordic Institute for Theoretical Physics. She has served as the lead on multiple papers, using existing survey data to find examples of exceptional astrophysical transients, including looking for physically impossible effects caused by highly advanced technology.
Dr. Beatriz Villarroel, welcome back to the program.
Thank you. Pleasure to be back.
Yet another round and new discoveries and the research surrounding transients, things that appear and disappear in photographic plates, has progressed. Give us a nice overview of your most recent research into the Palomar transients.
So now a few years have passed since we started with this topic. So it started with that we found these kind of objects, transients that appeared and vanished some years ago, and then we started finding some of them in groups that appeared and vanished. Then we automated the processes. So my colleague Enrique Solano, he automated the process to extract lots of these transients that appear and vanish on the Palomar plates. And we also have the Citizen Science Project, where a lot of people have been going through images to find similar types of transients. We have thousands of these from the Citizen Science Project, many more from the automated processes. So that's where we have been in the last years. Now a few years have passed since we started with this topic, talking about objects that appear and disappear. And we have progressed with this research. We have to try to understand more, of course, the nature of it. And one clue that we got was that we had some very interesting cases. We had a case where we saw a triple transient happening on the 19th of July, 1952. It was found by my colleague Enrique Solano when he did this automatic search for transients, and he found some 100,000 of transients. And then this triple transient was super beautiful, like 3 bright stars that appear and vanish. And as a coincidence, it happened on the date of the most famous UFO mass sighting, which happened in Washington, D.C. on 2 consecutive weekends. And this was a very, very interesting coincidence. And we have been exploring more of that, trying to see if it was just a coincidence, because we had one more candidate group of transients that appeared and vanished at the same time, where you can see 5 objects in a narrow band from the 27th of July, 1952, which is the second weekend of the Washington UFO flyover. And of course, when you have one coincidence, you say, okay, maybe it's just a coincidence. When you have 2 coincidences, for each from one of the 2 weekends of the Washington flyover, it was only 2 weekends, then you really start wondering, is there a correlation between the transients, these objects that we see, and UFO events. And so my colleague, Stephen Bruel, he used the data set of Enrique. He took this data set of Enrique. So this was a little bit like of a cleaner data set from the upper hemisphere, northern hemisphere. Something like 106,000 transients. They have not been visually inspected, so there's a lot of false positives there. There can be a lot of plate defect and other kind of false positives. Like one source of false positives is, for example, if you have one plate has slightly bigger depth than the other, then sometimes you get automatic algorithms get confused. Anyways, he took these two samples, and he has been looking for correlations in time between these transients and UFO events, and between the transients and nuclear bomb tests, and between nuclear bomb tests and UFO events. And guess what? He finds statistically significant correlations between all three. So they all correlate with each other temporally. Within one day, you can see these correlations. So that's kind of a cool thing.
It is, but that's not to interpret this as anything except a correlation. In other words, some people are going to say, well, it's aliens or things like that. But we can't really jump to those conclusions here. Rather, we just say something is correlating.
Exactly.
And it's very unusual. And in one of the papers, you go into a very strange phenomenon that was noted with nuclear testing, and that is Cherenkov radiation, basically blue orbs in fallout, areas where there was fallout, which is a natural radioactive effect. If you see the blue glow of a nuclear reactor, that's Cherenkov radiation.
Then you should run.
And
then one should run. I mean, if you see the blue glow.
Oh, yeah. If you see the blue glow, don't go near it. Well, actually, for that matter, if you see a UFO, don't go near it.
Well, that's the trouble. If I would see a UFO, I probably would run towards it.
It is, but one of the very few instances where the U.S. government paid out for an injured service person was a UFO, where they pay out for obviously many reasons, but the one that they were actually able to do was damage someone sustained from a UFO, which I think was Rendlesham Forest, as I recall. But anyway, if you see a UFO, don't run to it.
Okay.
And try to communicate with it, because contact the UN before you contact the UFO. But there's something else within this, that maybe the things people were seeing would be, an effect of fallout, an unknown effect, an atmospheric reaction to nuclear testing. But another aspect of this is that it stops. It just stops at some point, which I believe was 1956 or 57.
Exactly.
And that's it.
Somewhere there.
And and it no longer correlates. Tell us about that.
I think you already told the most important bit there. So I guess there is not so much more to add there. So it's like it really fits into the UFO nuclear in many ways. This kind of the correlations that we see, including the stop at 1956, when there was a reporting. They reported that they also stopped seeing UFOs in 1956. Funnily enough,
weird correlations for sure. Yeah.
Yeah, but weird coincidences in these correlations. But this is, however, not the most fun thing that we got. Well, it is a super fun thing, but I would say we got one more really fun thing, like with the transients. So you have all these people always telling us, it's photographic plate defects, and trying to convince us that this is plate defects we are seeing, plate defects that just happen to have star-like brightness profiles that look like stars. Anyway, one of the ways how one actually can test that, if it's plate defects or if it actually is what I more believe it might be, which is solar reflections. So let's say you have solar reflections, and they can sometimes, if you have an artificial object that is very planar and highly reflective in a high orbit around the Earth, let's say at geosynchronous orbits at 42,000, and it's sometimes reflects sunlight, then you will get something that looks like a transient instead of getting a streak. Because if something is inside our atmosphere and moving, let's say like a balloon is going to streak. So, but there at 42,000, you can get this transient. And what kind of test is it possible to do to say whether it's actually a plate defect or if what you're seeing is a solar reflection from an artificial object? Well, you are not going to see solar reflections in the Earth's shadow, right?
The umbra.
Yeah, in the umbra. If you look there, you're going to see fewer transients if they're caused by solar reflections. However, if the transients are caused by emissions or if they're caused by plate defects, they will be anywhere. Plate defects don't know where is the shadow.
What is the degree of confidence, statistical confidence, in these disappearing within Earth's shadow?
Well, if you take your entire sample and do a very simple test where you just say, you can estimate how a big fraction of the sky is covered by the shadow, then you're going to get a 22 sigma result that points towards a deficit in the Earth's shadow, a deficit of transients. However, you can do your test much more carefully. So you can try to take the plates that you have and you can estimate how big. So you know the plates, you know that when they were, like these plates were exposed, you know the right ascension, declination of each central point, and you can just calculate, okay, so how big a fraction of these plates were covered by the shadow, and you can compare with the transients. And you again are going to see that there's big deficit. And no matter how I've been trying to calculate it, I get a serious statistically significant deficit in the shadow. If I do it the more finer way, then we are at 7.8 sigma. If I do it more the brutal way, then I get 22 sigma. But there seems to be a deficit of transients in the Earth's shadow, which points towards that a fraction of them, maybe like 1/3 of them, are caused by solar reflections. Roughly 1/3, I would say, from the finer ways of estimating it.
Now, to expand on that, in science, 6 sigma is really, really solid evidence, right? And this exceeds that in any way you do it, right?
It does.
Now, to illustrate what this is with Earth's shadow, just imagine a a lunar eclipse where Earth is between the sun and the moon and blocking light. But during a lunar eclipse, it doesn't block it completely. There's the penumbra and all of that business. Does that still allow visibility of the transients if you are able to look at them with a much, much higher resolution and magnitude ability? Say you had a, 8-meter scope or something like that, much bigger than the Schmidt camera that took the Palomar plates. So could you see them still and verify them at a much lower magnitude in further research as they go into the Earth's shadow?
Well, I would only stay inside the umbra for safety. So I wouldn't even try to do it in any other way.
And so, in other words, they blink out like the International Space Station when it goes past the Terminator. They just blink out.
Exactly. It usually gets dark and you don't see it.
Now, was there any other... Now, some of these correlate in a line, these transients.
Yes.
And almost look like, especially in the original paper, it looks like satellite tumbling, tracking. Now, is that what these are, or is it something more along the lines that they are just simply in a kind of formation?
I have no idea. You can't imagine how much I've been wondering about it. It could be anything. Because what if they are just hopping around? If it's some UFO hopping around, then it's going to be even more confusing. What we can say is that you get some kind of transients where 30% are missing in the Earth's shadow. There's a deficit, which points towards that at least 30% or 1/3 of our sample. I don't remember the exact numbers now. It's somewhere in between 30% and 1/3 of our sample are associated with solar reflections. And the rest of the sample, it could be anything, including plate defects, I would say. But you still have this interesting sample where I think it seems most reasonable that they are at high altitudes around geosynchronous orbits.
Geosynchronous orbits.
Yeah.
In other words, they can basically hang and be a point-like source. However, you were able to characterize reflectivity and things like that with these and come up with possible geometries. Tell us about that. How reflective are these objects?
Well, so that's a simulation made by Hisham in Algeria. He's a postdoc and he has been doing lovely simulations. So he has tried certain different geometries, possible geometries that could produce this kind of glints that we see aligned in a line. And these are, of course, not the only shapes that can produce that, but he was trying out what is possible, what could possibly produce what we see, some of these examples.
And it turns out they have to be highly reflective.
Well, in order to get that fast flash that causes a transient, because if you have something that is very spherical, you're going to have a streak. Or if you have something that is not highly reflective, again, you are not going to have this extreme, this extremeness of having a transient there that is bright and then you don't see anything. For that, you really need it to be super flat and super reflective and at a correct altitude.
So correct me if I'm wrong on this, but to characterize that, it's like a mirror. In other words, say you have a tumbling mirror, and every so often it glints in the sunlight and you see it, but most of the time you wouldn't be able to see it because it's tumbling. Only when it aligns and glints do you see it. Is that a good way to express this?
One can say it like that, yes. And the mirror could also be like attached to some larger structure, something much more complex that only sometimes this little surface that you can, only sometimes you will have the glint from the surface, and other times you will not even see the object.
Or if the mirrors are moving, because with the Apollo missions, they placed mirrors on the surface of the moon that you can basically shoot a laser at and take a very accurate sounding of the distance the moon is from this. But if that wasn't aligned, you wouldn't see it. But since it is aligned, you get a reflection. And here they just seem to be randomly aligning in order to glint in the sunlight, right?
Something like that. Yeah, so that's why we have been looking for alignments. And I suspect that will have to extend these searches a little bit more, because I think maybe we should also be looking at larger parts of the sky, which is much more difficult, because then it's more difficult for the eye to spot this kind of transience during a visual inspection. But if you go for a larger, maybe you will even see the bending of the path. So that can be quite interesting to do. That's something I want to do. And actually, I also would like to start looking for streaks and things that might be more associated with objects at low Earth orbit. I simply want to do the maximum what we can with the photographic plates.
Yeah, if geosynchronous, then that limits what you can do.
Exactly.
Because you're doing something very specific.
Exactly.
However, you can eliminate, I think, at this point, plate defects simply by, and a lot of people are going to say, well, Kodak had problems with radioactive fallout. They were seeing it, appear in their emulsion, but that would be random, and it would not correlate with the Earth's umbra for sure. That's a glinting object.
Exactly, and the same with cosmic ray particles. I think the umbra result is really important, because it removes so many things, and it points towards real solar reflections. Of course, there is also a possibility that nature has produced some kind of objects that we just can't imagine today, because we don't know that they exist. We can't even imagine what it is, and they might be in Earth orbit, and they might be totally natural, just that we have no idea about them yet. But it seems simpler for me to imagine that it's something artificial just because it looks like what we see today on the sky.
Part of the problem with a natural explanation, though, is that when you have a meteorite or whatever, a temporary satellite that Earth can capture, doesn't stick around long because of the physics of that. Just for something like that to go into a geosynchronous orbit is asking a lot. A meteorite is just probably not going to do that, right?
Exactly, neither ice crystals or any dust particles and so on. So it's really difficult to come up with something there. And actually, let's admit it, aliens are also natural.
Oh, that's true. That's true. And I actually, one of the things that people often mention to me, they say, well, there's no evidence of aliens. And I'm like, well, wait a minute. You are proof of concept. We are someone else's alien civilization, And what do?
Exactly.
We crash saucers on alien worlds. Mars with the rover back shells were literally flying saucers. And so I'm careful to leave the option open, even though I'm a scientific skeptic on the matter. But I don't know where you would find an alien. Think about things like radio signals and planets and all that, but maybe that's not what they do. Maybe that's not what we're going to do in the coming centuries. So I'll leave the options open. What's your view on that?
Well, somewhere far, far away on some planet, there is an alien wondering if we exist.
That's true.
And they would be astonished to find out that we have this conversation right now.
That they're being talked about, they'd probably be disturbed by it. They'd probably be like, the humans are talking about us. But I think it has to be left open, though, that this planet has screamed its biosphere for over 2 billion years, ever since the Great Oxygenation Event.
Yeah.
Everybody in the Milky Way knows that this exoplanet that we live on, it has a biosphere, because they're going to see those weird oxygen disequilibriums and things like that. And eventually they'll see the Freon or whatever, the CFCs and things like that, and they're going to know. It's very hard to hide. You can keep your radio signals quiet, and we generally do, but you can't keep Earth's biosphere quiet. So it would be, if people, if the species of the Milky Way travel to stars, they know about this world and might be here. So you have to leave the option open, because
Exactly.
even though it's quite a trek to perform interstellar travel, physics does not prohibit it. You can, if you've got enough time. And maybe they have enough time. So you have to leave these options open.
And I'm somehow imagining that this could be like, it doesn't even have to be biological visitors. I'm imagining that it could very well be like AI probes that they sent out. Let's say they have infinite amount of resources. They send millions of AI probes to every interesting stellar system with an interesting planet that looks habitable and that seems to have some biosignatures. They could have sent millions of them here. And these little probes will be interacting and learning everything about humanity and about it. Well, maybe they were already here since the dinosaurs. And they will just learn more and more and more about us. Then they will come and interact sometimes. And maybe who knows? I mean, we have things like Neuralink already being built today. Maybe they have some stuff that can interact with our brains, which means why they are so confusing experiences when people see UFOs, because there's interaction between the brain and the probe. And you can have, there's a lot of things you can do with just probes. Probes doesn't mean an old Voyager style thing. It could be so super cool thing that we can't even imagine the tech that it uses today.
Well, I'll scare everybody, put on my science fiction author hat for a bit and say, all right, how about an all-powerful, godlike, artificial general intelligence, a von Neumann probe that can 3D print out anything, including UFOs that dip into people's atmosphere and they see them, and even print out aliens.
Oh my God. Now that is scary, if they're printing out aliens. As long as they don't print out, what was it called? This legend I think you mentioned the other day, Mothman.
Well, that's one of the ideas, but I mean, if you had it, okay. But I think I can actually add another dimension of scary to it, because say that von Neumann probe that's printing stuff out is millions and many millions of years old, and it's been corrupted by cosmic rays and it's behaving irrationally.
Okay, this is getting really scary.
That's my job. Now, anyway, back to the glints. Do you have a size profile? Do you know how big the object would need to be to reflect the way they did? So do you have any estimate on how big these things are?
No, we don't. This is something I want to get. I want to get also better estimates of whether 40,000 kilometers is a reasonable this altitude. There are works that have been done with, let's say, common space debris, today's space debris. And those that are more or less equally, like they have similar apparent magnitudes, they are usually like ranging between 10 centimeters to some meter or so. So it can be quite small stuff. It doesn't have to be giant things. It doesn't need to be the biggest spaceship one can imagine. Okay, so let's be a little bit more generous. It could range anything between just, let's say, a couple of decimeters and a couple of meters, just to make it a bit larger.
About the size of a satellite, basically.
Yeah,
roughly.
It doesn't need to be super, super big. And maybe why would they be sending big stuff? They maybe will send small things. Maybe it's easier.
Yeah, and maybe it is. And one could even say, one could invoke Breakthrough Starshot here, because what are we thinking about doing? Sending a very, very tiny probe to examine another star system.
Exactly.
And it's much, much easier. However, I don't think you could hide that. A giant laser with leakage and everything coming towards you, that's probably going to tip any alien that's there off that there's a probe coming. And that's one of the things that scares me. I hope we never see that. We detected a giant laser sail that's coming towards us, and it'll be here in 624 years. The entire human species would have an existential crisis. Now, in regards to the glints, one of the biggest things that I'm seeing as far as critical ideas floating around is balloons. And people are saying, well, maybe it's balloons because they had those at that time in the 50s, and they were launching a lot of them. But the thing is, it seems to me that you can't keep a balloon still long enough for it to show as a point-like source in a 50-minute photographic exposure.
Well, I mean, the telescope is tracking the stars. How is it going not to create a streak? So, I mean, the balloon will create a streak.
So it is. It's actually sidereal tracking for the exposure to keep everything still, but a balloon, it doesn't care about that.
No, of course not. Plus, even if by some magic it would blink, it still is slow enough that it wouldn't be a point source.
No, because it's spherical, right? Yeah.
It would be blurry.
Interesting. The other question you could ask about that is that a lot of them, they didn't have Mylar yet, or it wasn't widely used or anything like that. So they were just polypropylene, something like that, the balloons of the time, weather balloons and spy balloons and things like that. I don't know if that would glint or be that reflective either, right?
I doubt so. And if it would be glinting, you would get a streak.
Now, in the plates, other stuff. So you see the transients.
Yeah.
Was there anything else, though, that puzzled you, that you saw that, like, well, this isn't a transient is what we're looking for. This isn't a balloon or aircraft. Was there anything else?
I mean, we were thinking of asteroids, we were thinking of meteorites, we were thinking of all kind of things. And like when we first found this example, we were left with that it's some kind of contamination, or call it plate defects or emulsion flaws, call it anything like some kind of false positive, versus that it would be something that is either reflecting or emitting light in a high orbit. So this is the two alternatives we were comparing. So the whole time we have been working since is we are trying to add more diagnostic tests to test further which of the scenarios seem to be more plausible. On the other hand, we don't need to find out that you have, let's say, 500,000 spaceships. It's enough if you have one. So you want to really try to focus on the most interesting cases, I would say.
So an asteroid, though, that would seem to me to also not track with the stars. In other words, it should also streak to at least a certain degree. And that was
super far away.
Unless it's super far
away. Then it will show up half an hour before at the same spot, but it didn't. Yep. Here we compared half an hour before and half an hour after. And you see it in one image, but you don't see it in the next. And that's why we were...
You don't. And that was actually a major, before computer technology, that was a major way that astronomers would look for such objects. In particular, Clyde Tombaugh discovered Pluto with a blink comparator and looking for any movement manually, and he found it. And that was a legitimate way in astronomy before computers to actually sift the data. So it's a real thing. So that you would see that asteroid doing that, or I don't even know if it would. If there's an asteroid out there that you can catch in the Palomar plates, we probably know about that asteroid, and you could, cross-check it and see, because it would be bright.
There's the MPC,
yeah,
the minor planet catalog that you can check against. So it's usually easy to do. Yeah, well, we did all these interesting tests, and then there was in 2022, I wrote a paper, A Glint in the Eye, and that was a white paper suggesting on how you can further look for non-human artifacts, because we really want to find the most interesting cases among all these transients. You don't only want to look for multiple transients, you also want to see that they kind of look like satellites by being aligned. So we developed a statistical framework that was built on another statistical framework that was developed by an astronomer called Edmonds, and I think it was published in Nature journal. and where we used his statistical framework in order to look for if some alignments were statistically improbable or not. And we have been using that framework to try to identify the most interesting candidates. And we found a very interesting candidate that if you take a picture and you fill it with, let's say, transients, then you can calculate the probability for them to be aligned in a certain band of a certain width. And so Lars Mattsson, who is a theoretical physicist at Nordita, he developed this framework, and we applied it on the transients dataset, and we found a couple of candidates where two were statistically significant, and the best one of them has a probability in 1 in 10,000 for this image to happen, this unique image within this unique size. The interesting thing is that this was the image that happens on the second weekend of the Washington flap, where you see 5 objects in a narrow band. So just a coincidence. So
coincidence, but also the correlation with the nuclear testing.
Exactly.
I think that makes it very interesting.
Exactly. But we had no idea. So like when we posted the first version of our paper in 2022, we posted it there. We had, by the way, all the dates were set off, were 12 hours wrong were wrong because I did some transformation error when I moved from Julian dates to normal days. So we had to correct it in the new version. Now it's the correct dates, the correct times. And but if you look there, there were these 5 candidates, and another candidate there, one of the less interesting candidates, is candidate 1, I think. It happens one day after the famous 1954 UFO UFO wave. It was the day when there were most UFOs during 1954, and another candidate happened there. So we have now 3 out of 7 candidates happen near a UFO event. So we started having fun. Of course, that's why we were wondering about if there was a correlation or not, like coincidence or not. So maybe we will be using UFO events as a predictor and try to see what it leads to. I don't know. We need to really start thinking about diagnostics when we look at the transients and to see which ones are the most interesting to look into.
The UFO researchers in the audience will yell at me if I don't ask this question.
Okay.
Would the glints be consistent with a highly reflective saucer?
Of course. I think that's the best explanation so far. So,
well, it's just too weird, isn't that the umbra?
So I'm going to be completely straight.
Okay.
I do think that these are artificial objects in a high orbit when they shouldn't be any objects. I do think that. I had myself a proper shock when I've been working with these results and redoing over and over. It's just like, first, you don't want to believe it. You just say something has to be wrong with the calculation. You redo it, and then, but you will start feeling in the body that like it seems to really hold up no matter how we change and the routine, no matter how we try different maskings, removing the edges of the plate and all kind of things, and it's still the deficit stays there. And that's when I had what's called an ontological shock.
My own philosophy, though, is that what is. And if you can demonstrate your methodology and everything which you did in the papers, it is. That's it.
Yes, we will make the samples public soon as we have a decision about the papers, or we will maybe try to resubmit once more somewhere if it doesn't work the first time. But we will make the samples public. The code is already public. Everyone can just go in then and try to reproduce it themselves. And if they don't like our samples, they can do the new extraction of transients themselves everything is public. All can be done. I suspect that the deficit in the umbra will stay no matter what one does.
And that also eliminates, a lot of people have mentioned to me, they said, well, how do you know that it's not the digitization process and that there are artifacts from that wouldn't correlate this strongly with the umbra? It just, it should be
And
random.
even if you have 90% of defects there, let's say now, we can play with that idea. You have 90% of defects there and 10% is something else that you don't know what it is. Still, if you have a deficit in the umbra, you still have an important fraction of objects that are reflective. It's just that the amount of them might differ. Maybe you will not have 30%, maybe you will have 5% that's statistically significant. I think it doesn't really matter. It's just if you have the deficit itself, then it gets really, really, really interesting. Of course, I would prefer to find out that it's fewer objects than that it's too many.
True, true. Now, one
It's
glaring thing about looking at these old photographic plates is what's called the Menzel gap in the Harvard plates. This is separate from the Palomar plates. Is the Menzel gap where Dr. Donald Menzel, who was the head of the Department of Astronomy at the time, willfully destroyed a bunch of survey plates
yes.
for no reason. And I've never been able to track down exactly what his thinking was, because they're just plates sitting around. Mm-hmm. And there was another scientist at the time, Dorrit Hoffleit, that was hiding plates in her office to keep them away from Menzel. Tell us that story.
So he wanted to destroy a lot of plates. So Menzel himself, he was the number one top UFO debunker. And he was also the one that was employed by is it called employed in English? Or yes, I think so. Employed by the US Air Force to help debunking the Washington 1952 UFO flap. So they used his arguments to try to say that, everything was wrong, what people saw, what the witnesses saw was wrong, what the pilots saw that was confusions, and what the radar operators that was incompetence, weather phenomena, etc., etc. So Menzel helped the US Air Force to debunk this big event. And 2 months after, he becomes director of Harvard Observatory. And as a first thing, he asks his secretary to go and throw away or remove or whatever 1/3 of the photographic plates. And as far as I understand, also a lot of logbooks were destroyed, and Dorrit Hoffleit, she tried to save some of the plates in her office, and after that she fell out of grace with Menzel, who started making her life very difficult. So she eventually had to move to a different observatory. So she has this chapter called Persona non grata. I learned, by the way, that Menzel and Clyde Tombaugh, that you mentioned, also weren't the best friends. Menzel was kind of not very kind to Clyde Tombaugh when it came to his UFO sightings. And by the way, Clyde, I might misremember this, but wasn't he actually also searching for satellites around the Earth, like small satellites?
I don't know.
In the early 50s.
I don't know, but I do know that Clyde Tombaugh had seen a UFO that puzzled him in, I think, Las Cruces, New Mexico. And he was, after that, very much interested. Now, remember, this is the guy that discovered Pluto, the astronomer that did that.
Yeah.
And he also had a colleague, Lincoln La Paz, another astronomer, that also was keenly interested. And there was a history sort of none of them getting along with Menzel. But I have never known, and I must know 100 astronomers at this point, and I have never known an astronomer that would destroy data. Not one.
Except for Menzel.
Except for Menzel. He's the only one I've ever heard. Otherwise, the astronomers would protect those plates at all costs. Well, look at the Vatican, their plate collection. I don't even let you near them,
Amazing.
Whereas not here, not in this case. What other plate sets can you look at to try to verify this outside of Palomar?
So this is something I've been thinking about. Of course, it's one thing if we replicate the study, but it's much stronger if some other group replicates the study, because that's always going to be a much better proof.
More robust,
I think, if it's someone independently. So imagine something that would be really beautiful. Because these plate archives, they probably are suffering from lack of budget very often. They are expensive to store, and if you store them wrongly, then they degrade. So they're expensive to store. Many don't care about the photographic plates from 100 years ago. They say, we have our CCD surveys today. We see so much more. This is not so important for science anymore. It becomes almost a historical thing for observatories to take care of. But look, these plates are gold for artifact searches and for UFO searches. Now imagine each country, each government would give to their plate collection, because somewhere in every country there's probably a plate collection. they would give them $500,000 or euros or whatever, and they would ask them to digitize everything and ask them to perform some diagnostic test, like the Umbra test, to see if they also get transients, how many they get on their photographs, and also the fraction that can be found in the Umbra. Maybe there will be some that find nothing, but maybe there will be several of them that will yield huge deficits. And that could be so incredibly important for us. This would be invaluable information. And maybe these old plates, photographic plates, would in that case provide much more important information than most CCD surveys do today.
Just a note.
I think this will need to happen.
Just a note. There was, there are other reasons. Besides looking for artifacts, there are other reasons to look at these old astronomical plates and preserve them. And one example that comes to mind was back when people were trying to figure out Tabby star, KIC 8462852.
Yes.
They were trying to figure that out. They went back and looked at plates, even as early as 1890 from the Vatican.
Yes.
And they were trying to see what the brightness of this was. And they were able to establish, using a number of plates, that it's been varying in brightness for over a century. And that was all done through archived old photographic plates.
There you see, this is like invaluable information. And I find it's very concerning that people might not care for these collections. And think about Menzel. He went and threw away so many, and he even stopped astronomers from looking at the sky for 15 years later. I also know someone told me, I cannot say or reveal anyone's source or so, but someone also told me that he had a second episode of plate destruction of unidentified objects, but later in the 60s. I haven't been able to confirm this yet, but that's the rumor.
You know, just offhand, I wonder what the method of destruction was, because photographic plates of that period, that's silver emulsion. So, people would normally try to reclaim that silver. And I remember that was a thing that was going up into the 2000s, 1990s and 2000s, where people were buying industrial photographic plates from that period and scrapping them for silver. I wonder if he did that and tried to recover the cost, because one of the things he said was he was trying to cost cut. Well, why wouldn't you reclaim it? But if he was just throwing them out, then that wouldn't make sense.
What if you shipped them away to some secret vault?
They're sitting in the U.S. government's giant Indiana Jones warehouse next to the Ark. That's the other thing, is that, what if there was a national security reason and they're like, yeah, we need these, and that's where they went. But I'd love to know.
It could be. Dorrit wouldn't know that.
No, I don't. I didn't get the sense from her book that she was all that much into the loop. She was just hiding them, and Menzel actually moved her office next to the men's room to try to create problems for her. It's actually an amazing story.
Yeah, and later she also got sacked from writing some essays later in some popular journal, right? I remember something like that. Or do I confuse it? There was some popular astronomy journal, and she wasn't anymore invited to write there. I probably misremember it.
Yeah, and after Menzel, I guess, passed away or whatever, the skeptic after that was Philip Klass, the arch skeptic.
Yes.
And he completely destroyed Dr. James McDonald's career.
Yes.
Over his interest in UFOs. It's amazing what's happened and how sordid the history of this is, of just open inquiry into the subject. And I just don't understand that level of stigma.
Yeah, that is because there is this, the topic has been so stigmatized for a long time that many people react with a reflex. They react with emotion. So if they will make an analysis, it's going to be driven by emotion rather than curiosity. And even maybe the debunkers maybe sometimes also have this thing that not all, I'm sure there are good debunkers too that are like going in doing very solid work, but some might have this thing of that it has to be wrong. This cannot be right. So they maybe the same thing with MacDonald, that he and Klass, they really maybe he triggered something in Klass, that Klass became very aggressive on him. Well,
the funny thing about Klass was that in one of his books, he He actually posited that it's all ball lightning, all of it. It's all plasmas, all ball lightning.
That's true. Right.
Now, in our modern age, we know that's not true, not necessarily. And so his actual debunk was wrong, but it was also very hand wavy and dismissive, which I don't think you can apply that because there's just such a wide variance in what people see. You know, when they see something they can't identify in the sky. But what I wonder is if that you're actually seeing it. Let's do a thought experiment. Let's say somehow, and I know this physically is a problem, but we'll say it. If someone saw dark matter phasing into brief visible, somehow becomes visible, would the brain interpret that? How would it interpret it? I mean, would it see a UFO today and 5 centuries ago it would see something else because it doesn't know what it's looking at, like an optical illusion? And I wonder about that. Are we seeing these things as they actually are? What do you think about that?
I think we don't. I think we very often see the things as we imagine them in a certain moment, and not only we see. I think it's applicable on everything that we do, the interpretation and so on. If we cannot imagine a phenomenon, we might have difficult time both detecting it, observing it, interpreting it, analyzing it, experimenting with it. We might have no idea what to do with it.
That would explain things like Dr. Jacques Vallée's work, that your interpretation of it is what varies, and people from different cultures and different time periods would see something different. They would interpret it differently, just like how people would interpret the aurora borealis. I know that Chinese astronomers during the Tang Dynasty said it looks like billowing silk, which it kind of does. But they also would say, I mean, they would call it supernova, guest star, things like that, because they didn't know the context. And I wonder if this is something that we just don't know the context and how to actually interpret it.
It's super difficult to do research when you don't understand the context. You might try to analyze it in some way, but until after, when you actually got the complete context, then it's going to be so much easier, of course, to analyze something. But until then, I think that's one of the problems with the anomaly science. You see an anomaly, but you might not understand the context of it. So you try to target the experiment in one way. And I think that this is what happens with a lot of this UFO research. People see some anomaly and they try to study it. And let's say, I don't know, if they see a ghost, they might also try to study it, but maybe it's not a ghost, maybe it's something else. And just because they call it a ghost, the experiment will be flawed. So I think it's so challenging with the anomaly research. It's so different from the more orthodox things where you have lots of people who are developing protocols for doing a certain thing exactly.
I will quote two people.
Yeah.
And the first is Arthur C. Clarke. Any sufficiently advanced technology would be indistinguishable from magic, which makes it very difficult to understand something that you don't have any experience with. And the second is, and J. Allen Hynek famously said in response to this, is that a lot of people have the attitude that it can't be, therefore it isn't.
Exactly. So if they see something that looks no, this can't be, then it must be like just imagined or so. And I think it's a dogmatic attitude.
It is.
And then of course we'll quote Occam's razor, which is very dangerous to do.
I have problems with Occam's razor because sometimes the simplest answer isn't the most likely. I mean, often it is, but sometimes it's not. I don't think that, what would be the simplest answer to explain what the sun is? Well, you're probably not going to say a giant ball of nuclear fusion with all this complicated solar physics going on. You're going to say that's a god, as people used to do. But that would be the simplest answer, is that it's the sun god.
Exactly.
But
exactly.
so it wasn't the simplest answer. All right, Dr. Villarroel, it's always a pleasure talking to you, and I look forward to further research. What's next in searching these plates?
Well, I would be super interested in seeing if we can get some help from other plate archives, let's say like the Vatican, to see if we can reproduce the finding with the Umbra. So I think that's next. We're also waiting for answers from peer review, where I assume we're going to get lots of feedback on the experiment. And I guess maybe we will keep on exploring these interesting correlations, because what we want to do is to see if we can clean up the sample of the transients and minimize the number of false detections there. That's something we want to do, because if we do that, maybe we will get, who knows, it's possible that we will get stronger correlations between, let's say the nukes and the transients if we have better samples. So that's next. Accepting this big challenge. So
big challenge, but it's interesting. I mean, I'm particularly blown away by the umbra, because I can't think of any other way that could happen if it wasn't simply the Earth blocking the light. I mean, I just can't think of anything that could mimic that.
Exactly. And I don't think it's balloons. Sorry.
I don't think so either. I don't know what it is, though. It's a complete mystery. All right, Doctor, thank you for joining us today, and I look forward to more shows in the future.
Thank you. It was a pleasure to join, as always.